My name is Atakan Kurt. This is the data mining project video. In the project, I demonstrated the correlation pattern between the hotel data and the economic indicators joined to the table too, and we're gonna search for correlation. Are there any relationships? And we're going to predict if they are related to hotel reservation cancellation. And we are going to at next customer segmentation, if we can cluster them or not, and also for associations, if there are any. In the process, we're going to clean the data, manipulate it, search for it, draw graphs on it, create the model, etc. Let's go through first. Let's go through our data, which is looks like that in the CSV, which has a lot of features, as you can see, and a lot of data. The file itself nearly around 70 megabytes. This is the first code. The file name is Play-Doh, which I just mess around with the data. First, the code begins with importing various libraries that are essential for the data analysis and visualizations. NumPy for data manipulation and Panda for data manipulation too. Cufflink and Plotly for interactive visualizations to see and do observations on the data and the work we done. Matplotlib and PyPlot and Seaborn for static visualizations. And in here I close up the warnings, which sometimes in the next part of the code I didn't change. We can see some depreciated functions show some warnings. You can basically cancel them out with this code. In here we load the data set, which is hotel bookings row.csv, which is like this, bookings row, and the fhat function shows up the first 5 elements of the data. As we can see, you can see the hotel name, if it is cancelled or not, lead time, arrival year, etc. And at the end we can see the economic indicators in that time, what is like. We have, for example, CPI value, inflation change and inflation itself, GDP, fuel price, and this goes on. In here we show the display the number of rows and the columns. Basically name it. These are the name indicators. These are the counts and the index. We call it T, and show it like this. As we can see, there's like 120,000 approximately rows and 43 features. With the DFD types, we can see the features data type. As we can see, we have various type of datas, which has floats, integers, objects. Objects basically means that something like string, and the list goes on. in here we are selecting the numerical columns, which I wanted to. The purpose of this is to how if I need to transform categorical features to numeric features to do operations on them. This is for observation, because basically we select the include the objects for this is for categorical, and we exclude the object types. Column to list is basically calling them numbers that are here. We calculate the length of it and the index of it, and we count that and see. This is the displaying function. We basically call it with like giving the index value and the values itself. This is the height and width. Text auto for 2.2 seconds for showing and improving the visualizations, and this is a selected color. This is the title and the labels. As you can see, we have 30 number of numeric features and 13 categorical features. We show, and as we can see, we need to transform these to numerical to do operations on them in our next next operation, which is random forest prediction. Next, we look for null values in here. I basically sorted and the first 14 of them, etc. And this is for showing which feature has how many null values. As you can see, the agency, country, I don't know some of the some of the economic indicator names, which we don't need also. So this is for ordinal features. As I explained in the presentation, for example, if we showed it in one column, the above values of here would be stacked on top, and the values above here would stack below here. So it is hard to visualize and do observations on the data. As we can see, the cancelled basically has two Boolean values, 0 and 1, and lead time, which is how many days before the reservation time that is booked. As we can see, there is some outliers here, and this goes on. We have 3 years, 2015, 2016, 2017, arrival date of the month. So as you can see, the data is distributed like statistically equal almost. Almost every day has some data and bookings. One of the important features here, adults and children. As you can see, there are some outlier values, which is like 20 adults in one room, 40 adults, 60. And we have children's like 10 children, etc. Repeated guests is Boolean, babies. This is for observing and doing decisions beforehand to do our operations on them. This is for checking the unique values, which feature have like the most unique value. For example, is cancelled has 2 unique values. Address is almost like very different unique values. Reservation status, date obviously, and we have 180 country, which is almost all the countries in the world. And as you can see, the GDP and etc. almost same on all data. We can say that almost. It's not various like in Turkey. this is the describe function, which basically calls the distribution and count, mean and max of the features that we have. As you can see, let's show an example. Adults, number of adults in the feature. The mean of it is 1.8, so almost 2 people stayed in the one room. Minimum value 25% of them is close to 2, and the maximum of the is 55, which is probably outlier. This is my check outlier self-implemented function. What we do here is we look at columns. We divide it by this is for like in the lectures we called it statistical distribution detecting checking outlier. So we basically laying all the data on the X column. We distribute them, and we consider the below 25%, the first 25% to the average, and the 25% after the 75% is outliers. We count them, and we after that we append it to the outlier class. These are for coefficients, and this is for description for after in the showing area. This for whole data, and we call the function here to display it. We call it what do we do? This is the outlier distribution. As we can see, the lead time, so like has 3,000 outliers. And the adults, let me show the adults. Adults has like a lot of outlier detections. Many of them is like very below the average or above the average. As you can see, we have a lot of outliers detected by this method. In this, this is for showing better. To the outlier number in the bar chart, we sort the values in ascending order. We call it, again, labeling it outlier counts. We call the bar chart, we put the outlier index and the count of it, and the first ones that is fit to the 1200 width pixel. As we can see, the most of it from adults, booking changes, interest rate probably, and CPI hotel, and children number, and the list goes on. From here we can observe we need to check adult values. And this is for analyzing how many data belongs to which year. We give it a color for the donut chart. We initialize the figure. We give it a width, show legend. Legend is here, this part. We don't want to sort, there's no need. And the color and update, we call it here. These are for default function parameters. As we can see, most of the data belongs to 2016, and the second is 2017, and the last one is 2015. In this, we are checking booking cancellations and inflation effects in a line chart. We initialize cancelled with 1 and not cancelled with 0. For the x, we give it a inflation cancelled count values, and we give the inflation itself and the count of it. And we draw the line here, as we can see, and there's not much correlation between inflation rate and the booking cancel rate, because obviously this should be higher than this one, and this one must higher than this one. There's not much inflation volatility to observe a correlation between booking cancelled and inflation. In this, we are again the booking number versus the inflation rate. Again, it is the same. As we can see, when the booking number is increased, the obviously booking cancellation is increased too. We cannot say something about inflation and booking rate again. In here I'm showing the country booking, country code and the booking number. Portuguese has like 50,000 almost booking. French has 10,000. These are just for showing them. Again, this is for default function, calling the pi country for seeing what is the country code and the country name. In this, I'm checking which hotel has more lead time, meaning how many days beforehand to booking. And summing them for all the customers. And this city hotel, we have two types of hotel here, city hotel and resort hotel in the data set. The total day of that is this number, 8 million something, and this is 3 million something. In this, we are checking repeated and not repeated guests. For example, a person is coming to the same hotel for next year. Is he canceling or not? We call again the group data. We're grouping the data here, and we're shaping it for county and then labeling it with hotel. We are creating the bar graph here again, and basically calling 0 and 1s for city hotel and resort hotel, and 0 and 1 for repeated guest or not repeated, is a first time customer or not. As we can see, 2,000 of them is repeated, and for resort hotel is 1,000 something. If you calculate the percent of it, we can say resort hotel is probably better than the city hotel, because customers are satisfied and booking the values again, booking the same hotel again by the percent. Not much, but better than the city hotel relatively. Well, in this, we are summing up the waiting list days for each hotel type and creating a bar chart to compare city hotel and the resort hotel. As you can see, the 260 days for waiting, for resort to town not waiting that much. Basically in this file we showed the dataset has a lot of rows and columns and features that are numerical or categorical. We have several features have missing values which might need imputation and manipulation. Certain features contain outliers which might require treatment. Bookings over time, I mean, we have most of the bookings are from the recent years, showing an increasing trend. And higher inflation are not actually correlating with the more booking cancellations. And some countries have significantly higher bookings, like Portuguese. Resort hotel tend to have more waiting time, longer lead times than the city hotel. And city hotel are probably a better and expensive one. And let's go to the next file. This is the project main file of mine. We are again importing the necessary libraries: Pandas, NumPy, Matplotlib for plotting, and for preprocessing, label encoder, and standard scaler. These are for manipulating the data beforehand. This is for handling missing values, and this is for splitting the dataset into training and testing sets. And we also configuring Seaborn for a Matplotlib for better looking plots. We load the data again, we read the data, we preview it for checking errors, like if we loaded the data itself correctly, checking the shape, number of rows again, display the data types and null counts again, basically checking the values, same values again. I copy pasted from the previous file to show in every file itself. Check for missing values and calculating the percentage of it if there is a lot of missing values. Step 3 is the data processing part. This step is involving handling missing values, encoding categorical data, feature engineering, and normalizing some of the features, numerical features, which some of them have bigger value, which may skew our calculations afterwards. So we separate the columns into numerical and categorical values. For numerical columns, we use the median, the midpoint, and to replace the missing values, I use the midpoint, giving an average value. For categorical columns, we use the most frequent value to fill the missing values. And in the step 3.2, we are encoding the categorical variables. I used the label encoder to convert categorical columns into numeric values. For example, if a column has value like yes, no, no, yes, label encoder will convert them into 1, 0, 0, 1. Basically here we're training through them. Well, this step is feature engineering. I did this because it was one of the requirements of the project. creating, well, feature engineering basically involves creating new variables to better represent the data set. Dropping reservation status because it was correlating with the is cancelled. They were basically saying in the next parts when I was training the random forest algorithm, I missed this point, and basically the model was correct 100% because this and is cancelled was very highly correlated, so I dropped it for real world cases. In here we're creating the new features, total nights, we're summing the weekend and the weekday nights, total guests with some of adults, children and babies, average daily rate per guest, this is average price per guest. I show the newly created features and normalizing. We remove the is cancelled from numerical column since it's a label, not a feature to scale. Like we're looking for it. We're actually trying to predict it. We use standard scaler to normalize the numerical features. Using mean and the standard deviation. This way, all the numerical features are on a similar scale, not 1,000,001, and improving the model performance in the forest. We can show it here, all the outputs from the data. Data set information, we have the descriptions of it here. Arrival date, how many of them, like this goes on. Missing values summary. We have country, agency, has like some missing values, 181 of them. We are doing encodings. For example, countries, the numbers, meals, arrival date, months like January, February to numbers, hotel, city hotel or resort hotel, market segment, etc. The list goes on. We are feature engineering output here, total guests, total nights, average daily rate per guest, the price. We are normalizing the numerical features and showing it here. Step 4. In this code part, basically drawing plots to show it in a presentation and exploring. In here, that's a histogram of peak time to basically see how far in advance guests book their stays, how many days before they do the reservation. Let's show it again. First, they almost always doing it like 1 day, 2 day on the same day. Not much like 100 days beforehand. There are not that many of them. As you can see, the distribution. Let's look at the other parts. Step 2.2, 4.2. I count the number of bookings for each month. I'm looking for like which month has the peak month, for example seasons, which month is season, etc. Let's show it here. As we can see, the seasons for January at most, and May, June, July is the summer season, which is average high. This is the off season. March, April, May, off season. Let's look at the other part. This is like meal type distribution, not much showing anything. I just did it. I don't know why. Basically, distribution of meal types using the bar plot, and like understanding the type of guests. Let's show it here too again. No meals, most of them. Sometimes meal types change. Let's do this part. Average price month per month. We are calculating here. We filter out the bookings where average daily rate is greater than 0, basically to avoid embedded data, which is not a price at all. And we calculate it by month. We sum it all and dividing it by the number of it. Visualizing the average price and the seasonal hotel bookings. As you can see, the most expensive month is February, and this is the summer part. Basically, best month, the cheapest month to visit resort hotel or city hotel is May. This is the end of this file. Basically, we cleaned, transformed, and visualized, prepare for further analysis data. Yeah, that's it. Let's go to the random forest part. In this code, we are again importing the essential libraries for manipulation, visualization, pre-processing, and model training. The same libraries again. We again load the data and preview it, and the checking shape of it, copy paste from the previous files, summary, and checking the missing values, handling again, doing the same thing, creating features and okay, let's encoding the categorical variables is happening here too, which I did in the previous file too. Again, doing the feature engineering. Here, the same. We are again removing the reservation status here because it is very correlated. Normalizing again, same as before. In this step, this is again self-implemented correlation function. I use the Pearson correlation, which is like a standard deviation and correlations between the two features. We basically measure the linear relationship between two variables. If they are close to one, indicates like strong relationship. If it is close to -1, negative relationship, and if it is 0, negative relationship, one is going when one is increasing, the other one is decreasing. A positive relationship is they both increase or decrease. And zero means no correlation at all. We take in the means, we sum it up, we calculate the denominator of it, basically coefficients, standard deviation of it, we divide it, and we get the value. We do this for each feature pairs, and we are showing it on the heat map. And basically we are calling the first 10, which is very highly correlated, and the heat map, calling it here. Basically I'm saving the process data for not doing the same operation again and again in the next part, which is training the random forest model and the test model. Let's see the outputs. These are the data manipulation, and as we can see, this is the heat map. We can see the correlations, the economic indicators between themselves, as we can see, very highly correlated. Is cancelled, which we are looking for, is here, and as we can see, the darkest color is the deposit type and the lead type, which we're going to look closer at the next steps. In this step 6, we divided the test set and training set 80% to 20%. And we're calling the, I didn't implement this before because we did it in the homework. So we import the random forest classifier from the library, and we call the evaluation scores of them from the library to easy to calculate them. A seaborn for better the visualizations. We are initializing the random forest classifier here. Number of trees in the forest, maximum depth of the tree, ensures the random states, randomizing the feature selection team, and the decision tree at max can be 10 depth. We are training the model using the training data set and predicting using the test data set. We are evaluating the model performance in the step 7. We are calculating accuracy, precision, recall, and F1. Recall is not actually important in this type of prediction. Not very help that situation. Accuracy and F1 score is very important. We are displaying the values here. These are helping us to understand how well the model classifies bookings as cancelled or not cancelled. Accuracy score basically measures how often the model makes correct predictions, giving us a percent. Precision score and the balanced F1 score, precision and recall, gives a better measure to us. We're again printing them, feature importance, showing them, and in the confusion matrix, we're showing the true positives, false positives, true negatives, and false negatives, which helping us to identify misclassifications and how well the model performs. In this, we are displaying the top 10 important features. Let's show on the actual data. As we can see, deposit type, lead time, and the country is the most three important features for deciding is the customer going to cancel or not. Yeah. In here we are doing the trying to find best random forest parameters. This is very crucial for improving our performance of the model. I used grid search CV, which is a library to making things automatically. These are again initializing the random forest parameters. These are the depth, number of tree, etc. We are calling the grid search, so it basically iterates through all combinations of it and getting the highest accuracy model. And puts them in an array, and we display it. Defines the different values to test each hyperparameter. And we're again evaluating the whole model accuracy and the prediction, and generating the classification report, which is again a library for getting out the best classification model. And we again showing the best of it. Let's see, you can see the confusion matrix, which is very good. It has like 95% accuracy. We call in this, I'm trying to show if there is any correlation between economic factors and the cancellation. We are selecting the columns features of the economic features. If there are any missing columns, we are filtering them, calculating the correlation between them, and putting in a dynamic array, and calculating the correlation. And again, we are displaying it. As we can see, is cancelled. This is mostly in CPI from the hotel and the inflation rate, not very correlated. For others, negatively correlated. For example, like this, negative correlated. And that's all for the random forest. Next, go to the next file, which is a segment, customer segmentation, which I did. Again, we are using DB scan algorithm. We are using the PCA for dimensionality reduction because we have a lot of features. Again, we're starting by importing the essential libraries. And we define our helper functions, plot clusters, for basically giving the values and it's plotting them, because we're going to try with a lot of features. Basically doing it for less code. This is the self-implemented custom DB scan function. Well, I implemented the DB scan manually, grouping the points that are close together while marking the outliers as noise. And EPS basically means the maximum distance that point to be considered as a neighbor. Data is data of ours, and minimum samples is the number of minimum points required to form a cluster, which is in the radius of it. The algorithm works like computing the distance matrix for all points, and I use Euclidean distance, and we loop through each point with each other points, and if it is already assigned to a cluster, we skip it here, and we identify, if not, we identify neighbors within the EPS radius here, the first ones, and if the neighbors is bigger than the minimum samples here, we create a new cluster and expand, and we return again, we do the loop here and return the labels, basically returning the clusters, unique clusters. This was the function. Again, we doing our pre-processing of to our data, basically copy paste from the previous files. Here we are exploring the multiple features. It's cancelled lead time, arrival date, month, arrival date, booking behavior, stay characteristics, depending patterns, customer loyalty. Is it repeated guest? Previous cancellations, are there any previous cancellations? Bookings are not cancelled or not? Market information and other informations. We iterate over each group and clustering them. Let's show the results. As we can see the clusters, booking behaviors, stay characteristic, etc. Some of them has a lot of. I did like 10% of the data because it was taking a lot of time. Let's go to the other file before wasting a lot of time. Well, why I use DB scan, because it detects clusters of varying shapes and detects outliers, and use PCA because it was very high dimensional data, and PCA helps minimize the complexity while retaining important information. And let's go to the association file again. We're importing the important necessary libraries. Again, the same libraries, we are doing the same things, checking for missing values, doing the same data processing, handling missing values, etc. Same as the before. And here we are categorizing it. We are doing the feature engineering same as that I explained in the project main file, and this is the part that we use. I used again in previous file that I explained to you, Pearson correlation. And now we go through again. I explained it in the previous file. We're converting the data frame. Again, putting them in the data frame and showing for better display, and showing the top 10 correlation if it is cancelled or not. I mean, like measuring how two variables deviate from their means together and preventing it. We apply our function to check which features are most correlated with cancellations. Basically, here we're checking for patterns and associations, segmentations. These are for all displays. Here we go. Here, let's go through the top 10 correlated with is cancelled, is deposit time and lead time and country, as we discussed before. Creating the bar chart. It basically helps us visualize better. To me, it is the most effective bar chart, I guess. We examine the relationship between variables simultaneously, as we can say, and together. As you can see, lead time has this. Selected features have like cancelled or not cancelled. Total nights have like grouped here. Like a lot of features. This is like top features again in the vertical bar chart. I did this for presentations and selected the best looking ones for my presentation. Again, this is this gorgeous bar, total gets, etc. The customer that I showed the customer segmentation analysis here, which we can say the customer type is basically 2 in a 6th market segment. This was all basically this can give us what is correlated with cancellation and other for the TA. This can do business recommendation and decisions and focus on which we can do, what we can do with the customer type. Thank you for listening me. This was all. Have a great semester.